Okay, in this tutorial, we're going to look at the suitability of using the standard deviation test to describe a data set. And what you might choose to do is read through the couple of pages that I've included on the website, um, and which you can also see on your screen, which outlines some of the typical strengths and limitations that you can write about, which I'm just going to show you there. Now, what I'd rather do, though, is actually apply it to an actual exam question and show you what the mark scheme says about that. So there's the mark scheme I'll be discussing in a minute. But what's important when you write an exam question in relation to the suitability of a test is that you relate your answer to the actual part of the question. So in this case, we were asked to explain the suitability of using standard deviation to investigate the changes in the river's discharge. And we can see we've been given the river's discharge variations across 1 year from 67, 68. And we're also given the data for 2013, 2014. And we can see that we have quite different monthly totals in discharge across the years. We can definitely see there are peaks, but the peaks in 1967, 68 were much higher than the peaks in 2013, 14, which suggests there's been a change in rainfall pattern. We can also see that the average has dropped, which is also partly explained by the fact that there's less peak rainfall. Now, let's just bear in mind why we're doing this. Before we think about standard deviation, why are we comparing these two data sets in relation to a river? Well, the river's discharge has changed, and that in itself is an important thing. People live around this river. This river is important to the lives of people in Niger, and there's something causing this change. We don't know if it's to do with land management surrounding the river. Maybe it's to do with some kind of land use where the river water that's falling on the drainage basin isn't getting to the river. Or maybe it's a climatic change driven by climate change. We don't know what's causing this change, but indeed we are interested in the fact that there is a change and we want to mathematically explore the degree of that change, which is why we might be interested in describing it using standard deviation. So that's giving you an idea about why we do statistics in the first place. Now let's actually think about answering this particular exam question here. Is this a suitable test to investigate the changes in rivers discharge? Well, here's the mark scheme the exam board gave that year when that question came up. And here's the kind of things they were saying. So is it suitable? Well, the first thing the exam board's interested in is they're looking for you, the student, to be able to make a range of positive and negative judgments in relation to the use of standard deviation as it relates to the variations in the river flow data. So they want you to think like a geographer. Why have I used this test? Okay. Well, it's a really important descriptive test because it gives a far more accurate result than if we'd used interquartile range or just the range itself. And what do I mean by that? Well, let's have a little look at the data. If we were to use interquartile range, we would only be looking at the middle 50% of the values around the median. We wouldn't be comparing the data around the mean. And therefore, we wouldn't be using the whole data set. If we just looked at the range, that would tell us the difference between the highest and the lowest, but it doesn't give us any idea about how that is spread around a middle value. Okay? Although the range does at least show if there's been a change. But of course, a range can be affected by one result being significantly different. However, standard deviation tells us here what that difference is as a number and whether that difference is getting bigger or smaller. Therefore, more of the months, not just as the average dropped, but the spread around the mean has dropped as well. And remember, it's a predictive tool that's 68% probability that the rainfall, the QMEX, I should say, in the river is going to fall either above or below 527 around that mean. Let's go back and have another look at another aspect. Apart from it being a better test than using the range or interquartile range, because it's better at describing the whole data set, it's also not affected by extreme values. Now, I've kind of mentioned that already. The range is very affected by extreme values, as is the mean itself. Whereas the interquartile range attempts to address the effect of extreme values by only examining the middle 50% of values. Standard deviation looks at the whole data set, but isn't skewed or pulled aside by extreme values. It counts for them. It's more about describing 68% probability of one standard deviation around the mean. Okay, so what does it next say? It measures the spread of data from the mean, whilst RAIN measures it to extreme values in the data set. So it's a much more powerful tool than the simple use of the range. Okay, it's how things are spread around the middle, not how they're spread around the two ends of the extreme, in this case the range. Okay, now this next point is a really important point, and you can really unpack this for a number of marks. So why do it? Well, if we have two data sets, it allows for a much better comparative approach. So we can find out how standard deviation is varying in those two data sets. And I've talked about that already. We can see the standard deviation here is much higher in the 1968, 67, 68 years, and it's fallen in the 2013, 2014. And we can see, therefore, there was greater variance in the average month in 67, 68 than there is in 2013 and 2014. And notice I'm using each point in relation to the data set. So I'm always relating these points back to the data set itself. Okay. We can see how that is developed. So using the statistic to compare discharge allows us to see how the spread of the data around the mean has changed. And this is quite an important point, that it allows us to make a judgment on how river flow has changed in the 46 years. So the river flow has got a lower mean, and there's a 68% chance probability that a month of rain is going to be less, or not rain, of QMEX, of river discharge is going to be less in 2013, 2014, because we have a smaller standard deviation than it would have 67, 68. Okay, so that is the suitability. You can use any of those ideas. Those are how you apply ideas directly to a data set that you're given in the exam. Or you could have a look at a more general reason from the main worksheet about how standard deviation can be used and why it is a good tool or maybe not such a good tool.